Greetings and welcome to another edition of the Agile Uprising podcast. I'm your host, Jay Hersko. Joined with me, I have my good friend, even though he's Texan, Chris Merman. Chris, how are you?
It's way too early in the morning for this shit.
Oh, yes. You're an hour behind. Well, joining us from the future, we have repeat guests. We have Pini Reznik and Jamie Dobson from Container Solutions. Pini, good morning.
Morning. Nice to be here.
And good morning, Jamie.
Yeah, good morning. It's true. We're in the future. It's 2 o'clock in London where I am today.
How's the weather in the future?
It doesn't know what it's doing. It's raining and it's sunny all simultaneously. We were locked down because of the pandemic, and then April and May came, and we're still locked down because the weather's been so bad.
Mother Nature had different plans. So, to our listeners, we had a lot of feedback come in from the last time we had Pini and Jamie on when we talked about cloud native transformations. And a lot of the questions that came out were, we had a lot of good conversation, but people were asking for a little bit more detail. So what we're going to do today is we're going to chat with Pini and Jamie. We're not going to do DevOps 101. That would be too rudimentary, bore them to tears, and they never want to come back on. But we are going to talk conceptually about some of the things that go on behind this idea of cloud native and working on a cloud, right? We've all seen that horrible Verizon commercial where the woman talks about identity theft and my stuff is in the cloud, gesticulating to this amorphous entity. But there's a lot of technology behind that, and there's a lot of actual complexity. So we brought Jamie and Pini on because we're going to unpack that a little bit for everyone to just to better educate people on, especially Chris Merman, better educate. That was a shot I couldn't resist taking. Better educate people on what goes on behind the scenes. So last episode, gentlemen, we started the conversation talking about the quote of "It's not where, but how." And now we're going to really talk about the how. So you introduced 5 principles in the book, which I actually have it printed out here on my whiteboard. You can't see it because it's off screen. But I reference that frequently because, human beings love the 4 box, but at the same time, it's a very succinct summary of some of the stuff that goes on behind the scenes when we talk about utilizing a cloud.
And Jay, are we recording just sound, or is the video going out as well?
Oh, just sound. All
right, because I was going to say I'll just hold the book up to the screen, but I think that's not going to work. But it also means I can relax now if nobody's watching. That's also
I try not to do video because it adds a level of stress. Some people get nervous. No, the audio is much easier.
Jay's not as pretty as I am.
Yeah, that's true. I mean, my mom always said I had a face for radio, so it does kind of fit. So the first principle I want to ask you guys about, and this is one where even as someone who'd been knocking around technology for a while, I kind of got hamstrung with the idea of infrastructure or platforms as a service. Can we unpack that? And for people who are used to working in environments where when you deploy, you're always pushing to some server that's in a kind of locked door and a NOC. How does this differ, this idea of infrastructure and platform as a service?
It's at the end, there are servers. It's just the question where they are they, and who is maintaining them. And pretty simply, everything that was running in your basement or in some closed room in your office or in the office that you rented from somebody else, there were racks of servers, and now those racks of servers are sitting somewhere else, which is normally a massive warehouse somewhere in outskirts of bigger cities, very well connected with very high-speed internet. But the most importantly is not where the servers sit, but what the level of automation of those servers. Right? And those companies that build those clouds, essentially, infrastructure or platform as a service, companies like Amazon or Google or Microsoft or other smaller ones, or Alibaba, because they run lots and lots of those, they have no choice but invest massive amounts of it in automation. So essentially, in the past, you had to buy a server, put it in a rack, install all kind of crap on top of it, and all kind of different things, and then spend a lot of effort maintaining them. Today, you just run a single command or push a single button, and you have not just one, but any number of servers with any number of anything you like.
Right. So back in the day when some people, exactly as Pini described, were setting up servers over in the application development teams, we used to fill in forms. And I don't mean web forms, I mean pieces of paper. And we would write on them that we needed which version of the Java, the Java virtual machine, what supporting software, and then we put it in somebody's inbox. and then that machine would be provisioned, and then we'd get a note back saying it was ready. That was in a few weeks later. So obviously, once we had infrastructure as a service, then you can add an extra layer on top of that, which lets application developers deploy their applications much more easily. So in terms of just pure time saving, imagine that, a 4-week wait time to get a machine provisioned versus, well, I don't know, Pini, do you know? How long does it take to fill in a form on Amazon?
We can
do it right
to
now.
The next topic, if it's virtual machine and there are no physical servers, although there are some clouds will allow you to actually provision physical servers. Normally it's a virtual machine and it takes about 1 minute on average, depending what's running on top of that.
Which is wild. I mean, I've worked in shops where, like Jamie said, it was almost like a union. It was a union assembly line, right? Jamie gets the case and he hands it to Pini, who puts a network card, who hands it to Chris, who puts in the power supply, who hands it to me, and I get to run the cable, and then someone racks it. It's not only. So long story short is there to Pini's point, there is still hardware. It's just literally somebody else's problem, and you're paying for the convenience of, I click a button, that I have demand, that demand is met, and it's somebody else's maintenance nightmare. It's someone else's headache to monitor to make sure it's responding. Like Pini said, it's on demand, and I don't have to really worry about it because it's just there, less than a minute. Right?
Well, it's not just someone else's problem. Like it literally the whole as a service concept. I love that you all get into it in the book. Is that it truly says, like, you can go do it easily, right? It's not just available and easy to do. It's as Pini was saying, a touch of a button, right? So if I want software, if I want a database, if I want anything, all I have to do is just, you click a button and then it takes care of it for you. That's the part about anything as a service that I find fascinating. And also it's really scary to a lot of leaders. So a lot of the leaders that I talk to today, it's 2021 and they're still like, but wait, if I allow anybody to spin up anything that they need at any point in time, what's going to happen, right? Which is why FinOps has been a growing concern amongst leaders. Like when you have those conversations with leaders, do you find that it's still scary to people, this idea of things being available as a service?
There's a variation of this saying about, like, somebody asks a CEO, what if you invest money in training and people leave? And then he says, what if you don't and they stay? It's the same saying. What if you don't allow people to spin up servers in 1 minute and force them to do it in 3 weeks? Would it be better?
It's a psychological hump people need to get over. I don't think people quite realize when we talk about on-demand anything, because cloud and cloud native, if there's one like reoccurring theme, it's this idea of on-demand. What we really mean is we're solving the oldest economic problem known to man, how to match supply exactly to demand. And once you can get instant supply, like we get electricity from the plug, it changes what you can do and how you can do it. This is, of course, what infrastructure as a service or platform as a service allows us to do, move quickly.
Right. You keep up with, instead of waiting, so we talk about in my process focused days, we would always talk about the idea of a handoff being a delay, and a delay is the biggest suck out of a business, out of an IT shop, out of a team's time, is a delay. I had to fill out this form. I now have to wait for someone to go put that server on the rack and plug it in, kind of a thing. Well, now when you don't have that, you literally are taking out every single bit of waste, the major waste that we have in organizations, and yet there's still fear. It's like there's almost a comfort to that waste and delay, and I find that, of course, that ties into your culture piece. Why do you think we're so addicted to these like delays and waits
Control,
and stuff?
man. It's control. People want the illusion of control. I mean, I'm the chief executive of Container Solutions, and Pini, what are you, Pini? I can't remember.
Chief Revenue Officer.
Chief Revenue Officer. Of course, by the way, I did remember. We're both founders, and we run the business together, and we are always bound by, when to go quick and when to go slow. So that need for control is not completely imaginary, and you have to understand that the same people who might be scared of the cloud over there might be responsible for cost control. So it could be that people have split roles. So obviously, as people who are a bit savvy with cloud, we would never want to control that element. We'd have other ways for doing that. But it is part of our job to control the pace of things in other parts of the org. So it's not that people are completely backward. It comes from a sensible place, but modern development is much more fluid and, you know, cannot have these wait times that we used to have.
And I think it's there is very strong need of control, and especially because people in charge of larger development teams, organizations, they're typically, you know, our age plus, sort of middle-aged white men, right? And they need the control because that's how they grew up, right? That's what they taught in universities, and now that they cannot say, I don't know.
Right.
And in reality, it's not real control. It's illusion of control. The systems are just too complex to control them. You have to let them go because it's just no single person can understand the complexity of a system like Twitter, which is just an SMS effectively, right?
Yeah.
Right. So there was one other high-level topic, and I know Jay's really excited to get to the containers, and me too, right? But one other high-level topic I was really excited to ask about is whenever I meet with leaders and they talk about the cloud, the one theme that comes up a lot is the business case, right? Like, we need a business case for why we're moving to the cloud. Now, most of the time there is this idea of cost savings, right? And so I'm kind of curious from your perspective, when people think of the cloud, should they immediately think of it's going to save me money because I don't have to pay for servers on racks anymore?
It's not going to save money. It's and not because it's more expensive. It is cheaper because it can utilize the hardware better. And although you pay to provider more than you pay per CPU cycle, the point is that the consumption patterns change. It's so much easier to start new environment that people do that, and then you need to pay more. The real value is in speed and speed of innovation, speed of development, speed of delivering products to the customer. It's the opportunity cost that you are losing, not the actual cost.
Right.
We work with a lot of enterprises, modern and let's say more traditional. Nobody talks about cost. I don't remember the last time I discussed cost in relationship to the cloud. Today in the Financial Times over here in the UK, there was a story about, I think it's Moonpig. It's an online greetings card and gift company. Really good interview. It's about the cloud, about automation. And if cloud is now in the Financial Times, you could, you know, oh, that's a fire alarm. Sorry about that.
That's okay.
Oh, wow. You can keep that in for sound effects later. So if the Financial Times are writing about the cloud, that means in a way it's become mainstream. And even the article was about automation, speed, and the upfront investment. They touched on that with a really large upfront investment that was necessary in order to reap that value later. So I don't know anybody who's talking about the cloud. It's a path to innovation. These poor businessmen, and me and Pini are two of them, they go to do their MBAs and they get told, you must innovate, but nobody actually tells them how. And with digital products, the cloud and cloud native is a really solid path to innovation.
Right.
The cost monster is we have a series coming up where we dig into theory of constraints, so throughput accounting and all that sort of stuff. The cost monster it's not that it's going to save you money. It's what if you could spend the exact same money and exponentially increase your throughput, you exponentially increase your value delivery. That's where it comes down to, right? You're not even selling speed. You're selling, what if I have the same car, but I could win the Daytona 500 in my car, which I drive a Scion with 200,000 miles on it. That's a really interesting mental picture. But moving us along. So we've talked about the infrastructure and platforms as a service. We do have a large audience that's not necessarily software engineers. So when we think of containerization, how does one grasp that concept? At a dinner party, somebody comes up and says, "What's containerization?" How do I answer that?
For non-techies,
yes,
I can take this, Pini. Let me take this one. The only question I can answer. Right. Imagine, I did it on the whiteboard yesterday for a new member of our sales team. So So for non-techies, so a computer is a machine. We call them machines. Where's my machine? Where's my laptop machine? Now, obviously, to install software, you can have a virtual machine, right? Now, if the computer's under your desk or around the corner in your garage, it doesn't matter if that CPU is running at 5% or 90%, because you've bought the asset and the cost of the asset is stretched over time. No problem. Now, the problem is what happens if you rent that machine off somebody else? Now, you're not going to rent something and then only use it 5% of the time, because you've still got to pay for the machine every month like clockwork. So the trick is to keep it as busy as possible all the time. The way to do that is to take all the jobs you've got, stick them into a little box, and stick all of them boxes, as many as you can, into that virtual machine. And those boxes are containers. And of course, on top of the boxes, you've got Kubernetes that kills the ones that are no longer working and responding, brings them back up to life, scales them up and scales them down, making sure you get high CPU utilization. So all of the bean counters can rest easy, thinking, oh, yes, my machine is running at 90%. And now I'm going to turn to Pini and say, how accurate was that?
Was quite accurate. There's side effect of containers run on the same operating system, many of them on the same operating system, compared to a virtual machine that each has a separate operating system. Meaning every time you run multiple virtual machines on the same physical machine, every time you run another operating system, another Linux or another Windows. When you do it with containers, it doesn't happen. And the side effect or the result of it is that when we were talking to move from 3 weeks to 1 minute, now we're talking sub-second.
Very quick. They're very quick. And of course, what that means is if you look at an application, whether it's Netflix or Gmail, that application looks coherent to you as a user, but many of those features are connected to a single microservice, which often sits in a container. And so obviously people log in like once every month. So that microservice in that container won't be used very often. But the containers that have got the streaming microservices in will be exploding all the time. So it's simply a way to get value for money from cloud providers.
So let me go one level deeper than the non-techie explanation, right? Because in your book you talk about, so the thing, if I'm reading about, so again, as someone who doesn't deploy code, when I read through all the aspects of the containers, right, everything makes sense except when I get to the word dependency. And I kind of got hung up on that part of how the containers interact with each other, because you're packaging up not just the code and all of the data that's associated with that, but also those dependencies that interact with the other containers. How does that, like, how, again, you know, in the I'm stupid, you know, brain mentality, like, how do I rationalize those dependencies between the containers?
Right. So that is quite a technical question. So I will try to be as technical as I can, but without like, there is a tool called Docker, which is essentially the point where the old containers, they changed to containers started. What they invented is a way to put everything you need, all the files from operating system and all the dependent libraries and all the other things in the single box that is entirely self-contained and can run anywhere. Right, this is the magic that they created. There are all kinds of different optimizations around that, which I'm not going to go into. But very simply, when you build a Docker image, or today there are alternative tools to do that. Basically, when you build a container image, it's sort of like a binary, like old binary on Linux or Windows. And it's not just containing the application, it contains everything from the level of operating system, including the operating system, all the way up. So essentially, it will run on any Linux. Right? If you build it on this Linux, it will run on any other Linux in the same exact way. And if you have two images that have different dependencies, for example, Python 2.9 or Python 3, they are different in different containers. It means that outside of if you run two applications that require two different Python versions on the same machine, it's a nightmare. If you put them in containers, it's no brainer.
So imagine if Pini was writing a program in C typically he would send the source code to me and I'd recompile it and relink it on my machine. Life got a bit easier with Java. He could build a jar file and send that to me, but any dependencies that he used on his machine, and if I didn't have them, that jar file wouldn't work. Right. So what we talk about, this, what do they say, Pini? It builds on my machine, or it runs on my machine. Containers.
Yeah, it worked fine on my machine. If I had $1 for every time I heard that, Jamie.
Yeah, containers solves that one problem. It's literally it solves it, runs on my machine, because if it runs in your container, it'll run and move the container, it'll run on the next place as well. So in a way, you have to think about it as maybe recipes, right? If in the old days, remember that recipe box where you had to add an egg? So you would get nearly everything, but there'd be a dependency on the eggs and the milk and the butter in your kitchen. A container puts everything in there, which of course it means that it's potentially waste, because you might not need everything, but it guarantees execution, guarantees no disappointment later.
It's true there is a waste, because you need to bring the full operating system with it. But there's a weird magic happens when you put the size of the image in front of engineers, and they say, actually, that blown up operating system, we don't need that. It takes a gigabyte, right? The first containers were over a gigabyte in weight. Today you have operating systems like Alpine Linux that is 5 megabytes. Apparently, you can run an entire operating system in less than 5 megabytes.
And there's some really cool applications for this. So let's say I did have a C program for doing simulations. I could compile it in a container. That's called a compile container, and send it to Pini. So he knew he'd be able to compile using the same compiler. Or if you're a data scientist, you can run an experiment in a container, save the results, and that can be replicated in different machines in different places. So there's a lot of really interesting applications. And of course, one of them being that you can run thousands of these things on virtual machines using Kubernetes. So once that packaging element was taken care of, there was a lot of really special things you can do with containers.
And so, and now you're talking about, we're running thousands of containers on one machine. Kubernetes is the, what is that? That's the Greek word for what? The harbor master or something? Helmsman? Yeah, helmsman. So you're running all these containers on this infrastructure and platform as a service. And this is where the idea of orchestration comes in, right? This is where the idea of you go left, you go right, you go up, you go down, you're over here, you're over there. You're going to the Python 2.6 box. You're going to Python 3.2. Keep me honest. That's where the whole idea of orchestration comes into place. It's making the right things in the right places.
That's the old way of seeing orchestration, right?
Okay. Actually,
there is no difference in boxes anymore because of the packaging of containers.
Okay.
The servers are actually, it's like electricity. It's the same everywhere. The compute power is the same everywhere. Essentially, all the dependencies and the Python dependency and everything else is inside the container. What you do need to have is basically you have a grid of compute, and you have a bunch of containers that you need to schedule, thousands of them. The orchestration, what it does, it puts these containers on the grid in the right place. The responsibility is to rebalance the load. So some servers, normally, if you do it manually, you will put it on some service and then they will continue run there, and then others will be free and some overloaded. And orchestration just takes care of the grid maintenance in a way.
Okay.
So it spreads it out.
Yeah, so the way you orchestrate with containers is different because of the container. And honestly, the parallel with actual containers is 100% correct. Once we had a container standard for physical containers, how you move them around became standard. So it didn't matter what was in them, but you could manage your whole dockside with new cranes, new forklifts to make everything work. By the way, FYI, Kubernetes is the Greek root of the English cybernetic, to mean control system where you take feedback.
Here we go. That's going to show up on our next trivia question that we do on our Discord server. We had the last one was I went too far down the rabbit hole on that one, but I am going to come back to it. Funnily enough, we were talking before we started, Jamie, about the book I'm reading about the history of Luddites. And the author references Kubernetes as the precursor to cybernetics and all that. One of those random things that had bounced around there. So we've talked about infrastructure and platforms as a service, containerization, orchestration, automation, I think is self-explanatory, but can we talk a little bit about microservices? And as someone who's my software engineering started and ended with hello world and HTML on a website, how do I explain microservices to someone who's not necessarily technically savvy? And then how do I help explain this to the guy who's the bean counter, who's saying, wait, you want to invest what to do what? You're going to split this into how many pieces? Why?
Right. Probably best example I can think of now is like a building, a single building, right? Now you can build like a hut or something like very simple, and then it grows and grows and grows. It becomes like a cathedral or palace, but you're still limited to a single construction. What if you go beyond that? What if you want to build a city? You have to start chopping this in pieces, and then no one controls construction of city, really, right? Everyone building a separate building. So there's higher level architecture or city planning, but everyone is responsible to build their own building. So microservices are like those buildings. They allow you to grow much bigger than a single building, but they come at costs. They are very complicated. Right? A system that is a city is significantly more complicated than any palace. And we are transitioning from, essentially until recently, it was enough to go, it's called vertically, meaning building bigger and bigger palaces. And at some point, imagine you're Burj Khalifa, it's 1,000 meters high. You cannot go any higher, any bigger. You need to go sideways, vertically. That's where microservices are essential. What's very important in microservices is absolute independence of teams. So they have to build their own things absolutely independently from others, which imagine that same manager from the previous part trying to control everything. It is just impossible anymore. You have to rely on
it truly
all
democratizes.
teams. Yes.
It democratizes the building of things in the best way, right? As opposed to artificial hierarchy, right? It truly says, I trust you all to build your thing. We're going to build our thing, and we have the right guardrails in place, right? Technical and process wise, the right guardrails to make sure we don't step on each other's feet too much.
And even guardrails are not enough. Essentially, in the past, you would command and control would work the best in building a large constructions. Today, it's all decentralized. It's more market forces.
Yeah,
so
it's true. Yeah, it's more like a big city. It is true. And in a city, more than one person does the same thing. So I think, Pini, I don't know what you think, microservices, how do you build large-scale systems for a bank, which is like an organization? In the old days, we had legacy or monoliths, and we said, oh, it's a big ball of mud, but the complexity was hidden, and now it's spread out. If you visualize the microservice architecture, you see messages passing back and forth. But how does a large bank run all of these systems and give the autonomy? We know that autonomy motivates people, and we know that small teams looking after a couple of microservices have got both autonomy and motivation. But in the old days, we didn't want duplication. So if somebody was building a password microservice, nobody else was allowed to do it. But actually now we're changing. We have more tolerance for duplication, and the open source model of developing, where we speak to each other with PRs, we often have duplication that we might merge later, we might not, or we have arguments, so we might fork, and we get two versions of the same microservices. What we control, Chris, the guardrails is more about API and API management. That's more or less where it ends. So what we used to do in open source, we now do within the organization. So microservices is because of what we need to build. The open source governance models is the best way to do it. And it kind of looks like a city because it's massively distributed and people are following design patterns, but not necessarily speaking to each other. Because I don't know what the woman in Hampstead Heath is doing, but her garden wall looks a bit like mine in Greenwich.
That's a great, I'm glad you used the example of a bank, because whenever I have to explain microservices to somebody, I talk about, in a previous life, I worked at a very large international bank, and there was no concept of microservices. And I was managing the IVR team. And the IVR, the mobile app, the contact center desktop, and the website all use the same account lookup service. And every once in a while, someone would take a spanner to something in production and it would go down. And I was always the first one called because I owned the IVR. And this was typically the first point of contact with most of our customers. So I would get an outage notification. They'd say, well, you need you to sign on because the IVR isn't working and customers, are having problems. And my next response was always, are they having problems with the website? Oh, yeah. Are they having problems when they drop the call to the agent? Can the agent find their account? Oh, no, they can't. Okay, so it's not my problem. Call the shared service guy. Call Pini. Have him look at whatever one of his people did because it's not me. And that was the best argument I've ever made to say to someone, this is why you want to, that's why you want to split these services up is when someone inevitably breaks something, it's not going to take the entire infrastructure down, which is what we dealt with whenever that would happen, because one universally shared service like that kneecaps everything operationally. And it was not a good look. And nobody ever liked me when I was, did Jay get on the call yet and tell us it's a service layer? No. Well, somebody check the service layer before Jay comes on and starts yelling. Yeah. So one of the things you just talked about, Pini, was a perfect segue. This is very, very complex. Yes. We are introducing a level of complexity and just multiple pieces moving simultaneously that it's almost kind of hard to grasp. And with that, my first thought was, along with that complexity comes the security concern, right? Because I'm spinning up services. I may not know exactly what I should be doing. I could really break something really badly, right? Because I'm just, road to hell paved with good intentions and all that. How does one get their hands around the complexity monster?
Specifically, security is, security always will be a challenge. It's always, cat and mouse game. There is never a winner. There is always some sort of a balance. It is different. It is significantly different in monolithic world that can be protected with a wall. Here, things are running in all kind of places. But if you're running in the cloud, people are afraid of cloud security. This is actually not reasonable at all, because cloud is probably protected much better than your own data center. In general, how you deal with complexity, you have to create next level of abstraction. You start hiding complexity with, like, in the past we would deal with bits and then bytes and stuff, and then created languages like Java, right? C going from C to Java, you hide a lot of complexity. Then you go to next level and next level. So every time we create next level of abstraction that hides all this complexity below. That's why we are going now into microservices and all kind of bigger terms. Yeah, but at the end, distributed systems are inherently more complex and complicated compared to systems running on a single server. And it's just different way of working. It introduces different.
My argument was, well, you're worried about security, right? Oh, we can't put this in the cloud because what if someone gets in? And my response was, Amazon probably spends themselves more money per year in just trying to make sure that their stuff is secure and they're consistently proactively monitoring than we spend in probably 10 years of an IT budget. They probably spend that in 1 year. So economies of scale, odds are we're better off with them than, relying on Jay, who didn't have enough sleep because he was up late playing Call of Duty, trying to rack a server and networking it all together. It's
security problems. The security problems change shape. So you can still introduce application vulnerabilities just because it's up on the cloud. And so I think people moving into microservices for the first time, they're right to be scared. The attack vector gets larger. And back in the day, most people know this now, but back in the day with containers, somebody could put a dependency in there and then the container would rebuild. But if the dependency was in a public repo, so this is called container provenance, where does the image come from, where does the dependency come from, you could inject a malicious one. So the attack vector changes, so people might be very comfortable with monoliths or whatever they were doing, and all of a sudden this is something new. I think people are right to be cautious about that. I would say that's about powering up. What does the attack surface now look like? how do we mitigate that? But obviously, an out-and-out statement, our data center is more secure than the cloud. This is patently ludicrous.
What's interesting is, like Penny, you were just describing the various abstraction layers. It almost is the way that we used to build. We talk all the time about rather than having giant requirement documents, right? Having smaller, more contained requirements. It's the same thing applies to things like security, right? So by breaking security into smaller layers that you don't have, instead of one single point of entry, one single point of failure, one giant monolith of security, you're not relying on just that to make sure that everything is secure. Because if that, back in the days, if you want to hack something, you go after that first. And then once you get through that, then it's a kid in a candy store. Whereas if the complexities are layered into it, it's not a single point of failure. And we're doing the I'm trying not to say the word agile as much as possible in this, but it is the most agile thing you all do, which is break these things down into small pieces and make them work together in concert.
Yeah, and there are new challenges. There's no question about that. But they're addressable, and there are new tools being built, new technologies created, and security is not worse. I mean, generally, securing a single building or securing a city is a different challenge. It requires different skill, but it is possible, and there are people doing it more successfully than ever before. I think modern tools, although they are much more complex than before, they are actually much more secure than the tools that are running on a single server in the basement, maintained by a random person.
Whenever the security concern comes up, I always think of the weak point in all these security things is us as humans, right? You both probably saw, I know you're across the pond, but you both probably saw the Colonial Pipeline hack that we just went through with the gas system, where that was introduced into their network by a piece of spam that was sent to an engineer that said more like Kansas City Chiefs, am I right? And it was a woman who was particularly well endowed. And the guy clicked the link to get more pictures. Human beings, and it introduced the malware into the systems. Human beings are always going to be the weak point. We're always going to be the weak point. And I know that with all this complexity, right now we have things like site reliability engineers, right? Which this is a lot of their job is to look at this. I know you guys have, isn't it WTF and is it SRE is coming up soon?
WTF is SRE. It's happening actually this week and at Thursday. It's a conference with over 3,000 attendees these days. And we're trying to answer the question and figure out what SRE is and how it's different from other ways to operate software.
Well, 3001 because Merman's going to be signing up after this meeting.
I talk about it every day with clients. It's so funny that this idea of like just the words, how do you define a site and how do you define reliability? Those are the most interesting conversations I have every single day. And with it, just like anything else, right? If we're democratizing everything with modern development techniques, right? We're not just putting in technical guardrails. We're empowering teams and individual engineers to say, I'm stopping the line because our SLI is getting close and I don't even want to get to breaking an SLA. If we've broken an SLA, we've gone too far. So how do I even say, well, we're getting close to it. I'm enabled, I'm empowered. How do I can stop the line and say, I'm going to fix this stuff for the betterment of everything. Like, it's just a fascinating concept. And to the point that you two were talking about control, like that scares the ever living mess out of enterprise architects. Cause they're like, wait, any team member can stop the line. Hold on. We need to talk about this.
Let's rethink about this. Let's form a committee and have another meeting. Well, gents, we're quickly approaching time and I want to be respectful. I just have one final question and it's to Jamie. Jamie, what were your thoughts on that absolutely disastrous attempt at creating that spin-off Mutant Premier League, Champion League? What were your thoughts on that?
Pini's more of a football fan than me. Do we live in a... Can I swear? Am I allowed to swear?
Yeah, absolutely.
Our world is fucked up beyond all recognition. At the bottom of my hill in Greenwich, 2-bedroom house. Now, I don't know what dollars to pound conversion is. 2-bedroom house, 1.4 million pounds. So it's not even a house, it's a flat. This is new and affordable housing in London. When you change something with a function, a house, a football club, a street, into an investment vehicle, you corrupt it into oblivion. So the house no longer serves a purpose to anybody except a rich person. My next door neighbor I discovered recently, because they're never there, is a billionaire investor. And the return on the house in London is better than the return on the stock exchange. So we live next to an empty house. So I won't blame American businessmen. That's not fair. The Glazers are American, who own Manchester United. You change football into, you take away its purpose and change the whole damn thing into an asset, a chance for a return on investment. Oh, fuck them all. The only hope, the hope in this was everybody reacted and said, no, enough is enough. But all that means is that the capitalists will retreat and make a new plan.
Right.
They'll come back in a year.
Right. Penny, what were your thoughts, Penny?
Pretty much, yeah. I didn't expect it to collapse so quickly before it even started, but it was actually, for a moment, it was like an interesting new competition. Would be interesting to watch it, but then 2 seconds later, this makes no sense at all. What about the rest of them?
Yep. I tried to explain. I'm sorry, Mervin. Go ahead. No,
I was just gonna say what's funny is Jamie on his rant about investments and everything, he was actually repeating like the morals behind why would you want to go to the cloud, right? We're not like, this isn't an investment in money and trying to turn what we have into a money making operation. Like, we're trying to make things smoother and easier, whatever. So like in his own, I don't think he intended to, he just made the perfect analogy of cloud transformation. It's you eat and breathe this stuff so much, Jamie, that it just comes out of you, even in a football rant.
I had a coworker, software engineer who's not into sports, ask me, explain this to me. Okay. And then explain why this is a big deal. And I said, well, I'll put it to you this way. I said, here in the States, we have all these pro sports and we have franchises, and franchises move. And when, Chris Merman's in Dallas, when the Dallas Cowboys announced they're going to move somewhere, what do the fans do? They hem and they haw and they protest, but eventually the dollar wins out, to Jamie's point, and Dallas and the franchise moves. I said, you have to remember, some of these football clubs overseas, they're over 100 years old. Right? Like it's like getting something handed down by your grandfather. My great grandfather was an Arsenal man, and my grandfather was an Arsenal man, and my dad was, I said, we're more laissez-faire fandom. I said, over in Europe, if they try to move that football club, they're going to show up at the owner's house and torch it. Right? There's going to be riots. I said, it's a cultural identity thing. It's not here where we're kind of just like, yeah, I'm a fan of this until I'm not. And they said, oh, really? I said, yeah, it's a lot stronger, back to the Luddism, right? There's a cultural bond that comes from there. But in the old
days, you would have had a bond to your football teams. And the problem is the model has disconnected that emotional tie to the point that you've probably never experienced it in your lifetime. And people over in Europe are like, we do not want this to happen to us. So the reason why they'll succeed with this European Super League is because people do get used to it, and people will watch, because they'll say, well, we do it in America. How can you move a city's football club called Dallas to a different place? But then what's it called when you move it? Something else.
Yeah, that's
it wouldn't
why
happen in my city.
Well, no, it wouldn't happen in
Texas
Texas because they've all got guns. But that's why you have things like the Utah Jazz, which was originally a New Orleans franchise, right? There is no Jazz in Utah. There's Mormons and skiing, but it moved. And, the Lakers were Minneapolis, land of 1,000 lakes. They went from Minneapolis to LA, and now they're the LA Lakers. It's kind of makes sense.
There's important points here about the rest, right? When I said the rest, what does it mean? So my son is playing football. Right? He's 16 years old, from age of 6, so 10 years playing football. It's quite a nice club, and there's hundreds of them in our area and around Amsterdam. And they all cost money, and we don't pay that much to justify that, right? So what happens is that the money from these big games, they're going throughout the pyramid all the way to 6 years old kids, and that feeds back into those clubs and generates players like Messi and Ronaldo. Now, if you say we own Ronaldo, right? So we will just take 80% of this money to ourselves from that pyramid. What's the future of the football?
Mm-hmm.
Like,
I think
the money is not going anymore to kids. It's going to those people. The money is there, it's true, but they didn't create it.
No. I think we've discovered our next offshoot podcast is going to be all sports. We're going to grab everybody randomly we can and just yell about sports, curse and swear in the whole nine. So gentlemen, if people want to get more information, they want to get in contact with you, they want to learn more about Container Solutions, where do they find you? Where do they go?
Container Solutions is, we have a website. Right? It's actually quite nice. You still can download the book for free, the entire copy. And this week we have a conference, which is also a nice place to meet other people and know more about SRE.
Awesome. Well, on behalf of Chris and myself, Jamie, Pini, I want to thank you for taking time out of your day. On behalf of the four of us, I want to thank all of you listeners for tuning in again. Blah, 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 blah. Discord, Patreon, subscribe, reviews, the typical canned response. Once again, thanks, everybody. And until next time, this is the Agile Uprising Podcast signing out.